Let's talk about C strings. A C string is a variable length array of characters. It is impossible to write a well-structured program without using these strings. So some languages such as Pascal, C++, Java, they provide intrinsic string types, but C programming language does not. In C, the programmer implements strings. Because they are so important, we write functions to manipulate them. But before we get into the function implementations and the concepts, let's understand the basics properties, right, of a C string, what that means, what a variable length versus fixed sized array of characters, their differences with respect to string and characters. Let's also look at how we declare, right, initialize our string instances, how we use assignment operators to manipulate them. Lastly, how we read and write those C strings. And they're different than those C++ strings. And we'll talk about those in a little bit. Let's look at how we store C strings, right? So a C string is a variable length array of characters, meaning, you can have a C string that says hello, right, as the example here illustrates. You can have also another string, saying college, right? So you can define, right, and declare these C strings. One thing to note is that C strings is an array of characters, and these arrays are of variable length, right, depending on the size of your string. The other property for a C string is to have this set of end of string delimiter, and this is a null character, right? Null character. So this null character is actually, has a value of 0 associated with it. The most common delimiter is the ASCII null character, right? So this null character is actually the first characters in the ASCII character sequence. So this \n, right, as you see here on the screen here, is what's used and employed by C to indicate that we are at the end of the string. And note that the null character itself does not represent a part of any part of the string, right? The string here that is in question is actually the green boxes representing hello. Another thing about this null terminated C string, right, is the fact that when you were talking about a C string, let's say hello, right, notice that there are 1, 2, 3, 4, 5 characters. The actual size, right? And each of these characters is actually 1 byte, right? So the total size for this variable length string that represents hello is 5 bytes, right? Because there are 5 characters times 1 byte, 5 bytes. But in computer, this null string takes another byte, right? And notice that this is just another character representing 0. This null character. This is 1 byte. So whenever you have a C string, right, you count the number of characters, that's the number of bytes. But you have to also be mindful that at the end of the string, there's a delimiter, null characters, null terminator. So you need to add another byte. So that's the total amount of storage. In this case, what is needed to store a C string is 6 bytes. Okay, so it's always the size of a string plus 1. That would be the storage size. But the length of a string, right, which is different. Length of a string does not, right, take into account of the end of the string delimiter. So length of a string is simply 5 in this case. This example illustrates 3 things. First of all, we have a character H. Okay, so this is 1 byte. The second one is a string, right? This is the difference between string and characters. Now notice that with respect to C string, right, there is a null terminator, right? So this null terminator takes another byte. So this is actually 2 bytes, right? Whenever we have just the terminator itself, which is valid, this is what we call empty strings. And this is what we call empty C string, right? So notice that the character only requires 1 memory location. However, a C string requires 2. Why? Well, because you have the character itself plus the null terminator, right? This example illustrates two things. On the one hand, left hand, we have what's called C string. And this is a variable length, okay? Variable length array. On the other hand, on the right side, this is what we call array, right? Array of what? Characters, right? So this is not a string, right? This is simply just an array, a fixed size, right? Right? You might be arguing, you know, what's on the left side here is fixed size as well, since we only have 5, right? 5 characters inside a hello. But that's not the point, right? The point is that with respect to any C string, you can have, you know, a C string called delimiter, another C string called differences, another C string called character, right? So as you can see, it depends on the length of your string. This what's being represented, right, on the left side is the variable size length terminated by this null string. So that's kind of the differences between the two, right? So in summary, the major difference between a C string and character array is the fact that C string itself and it's a collection of characters ending with a delimiter, right? This null terminator. Whereas the character arrays is a collection of characters also, but without this delimiter. This example illustrates one thing. One is when you're storing a C string, right, inside this array of characters, as you can see here, really the C string itself is an array of characters with a null terminator. So sometimes you may have a string buffer. In this case, this entire buffer is of size 11. So there's actually 11 slots in there. And because the size of your variable length, right, string, in this case is of 1, 2, 3, 4, 5, 6, 7, 8. There's only 8 characters here, plus that one null terminator. You need a total of 9, right, characters to store this entire good day string, C string. And because your buffer is 11 and the total size is 9, you have sufficient, right, storage space to store this entire good day, right, string. And what's going to be a part of your leftover is what we call undefined, because we don't know what is stored in here, right? So technically, at runtime, right? So when you try to print out, right, this would be the 10th, right? And this would be the 11th characters. You could be getting anything, right? Because we don't know what is in store inside this memory space, but we know at least for the very first 8, right, bytes of your memory inside this structure, you have good, right, space and day, right? And the 9th location is a null terminator, which is 0, right? Which is 0. So that's how strings are stored. Another way of looking at this is whenever you have an array of a character, as long as you attach, right, this null terminator, assuming the space is available, allow you to do this, you will end up with a C string. So in this case, what you have here is simply a C string requiring 9 bytes of memory storage space inside this 11 byte array of characters.